Hello everyone. Good morning. Yes, but in last class we discussed about the physics. So what is physics? We discuss about why we are using physics. Then we understand about the physics. Then physics in our nature so much helpful. In technology we are using physics only. So everywhere in our regular daily life we are using this physics only. That's why we first you try to understand this physics. That's why we can start this one. Our next topic here, force, fundamental force in our nature. Okay, first one discussed better this one here. Four type of the forces in our nature available. Gravitational force, next year electromagnetic force, next year strong force, and next year weak force. There are the four type of the fundamental forces are available in our nature. Okay, so we discussed already your first type, your gravitational force in last class. Again I am telling about this one, your fundamental gravitational force. Gravitational force always will act between the two heavily mass body, means having mass of the two bodies, then only this gravitational force will act, and having distance between them, then this force will be directly proportional to the product of two masses, and you are directly proportional to the inversely proportional to the square of the distance between them. So this force will be equal to your F equal to G m1 m2 by r square. Okay, force we know that about this one, your vector quantity having direction also, its direction can be toward the earth and away from this. So your force having two types the nature, attractive nature and repulsive nature. Some forces are attractive nature, some forces are only repulsive nature. Mostly forces having both type of the nature, attractive as well as the repulsive. So gravitational force, one of the forces which are having attractive in nature. Nature is attractive. Any object in our universe we are falling anywhere, then always will come toward our earth. Okay, this gravitational force beta not for our earth only, that in complete universe this force is exerted. Okay, so here first time Newton told about this one gravitational force. Who told about this one? Newton. Okay, Newton sitting in downside of tree of the apple, then apple falling downward direction, then Newton thought about this one, why this apple is coming down only, not coming in upward direction. Okay, then first understood about this one, why it is coming down, then Newton thought why this one. So given this one law, that universal law of the gravitation. Okay, in our physics beta we are reading about the laws and some theories also. So laws and theory, what is the difference between laws and theory? We know about this one, some laws and theory, laws and theory. Okay, our scientists given laws and theory. So laws which can't change about this one. Laws are given by our scientists that we can't change about inside the law. But theory in future, if something you want to change in this one, any topic, then we can change theory of that. Okay, but laws can't be changed because these are the actual happening in our nature. So according to that, for example, Earth is revolving around the sun. Okay, Earth is revolving around the sun, then always their law, which one is the actual that is acting on this one, that is a universal law of the gravitation. Due to the gravitation, this is acting toward the center. Any object is falling down, there also gravitation law is acting. So we can't change these laws beta in our physics. So gravitation first time told by the Newton that everything is a falling downward direction only because earth is attracting every object toward our surface. Okay, so here having attractive nature only, not having repulsive nature. And this is not for our earth only, that is a universal law of the gravitation, means in the complete universe anywhere is acting this attractive nature force between the masses body, then their gravitation force is acting. Okay, that is not so much that is a strong force, that is weak force as compared to strong force, as compared to electromagnetic force. Okay, and having the long range order, here not written but a long range order. What is the meaning of the long range order? Long range order means long range order. Okay, meaning of this one, till your large distance we can find this one force for the not short distance. For example, if we are taking the two magnet, okay, two magnet we are keeping like this one distance, then as we will bring these magnet away from each other, then we will see they are not attracting and repulsion between them. Yes or no? For the short distance, that they can be attract, they can be repel with each other. But as we will increase the distance between them, then we will say, we will see then they are not attracting and the repulsing between them. But as we are throwing any object from the long distance, then always they come downward direction always. Okay, so we can say this gravitational force is acting for the large distance. That's why we are calling it long range order. Okay, so each forces are dividing into short range or long range. Okay, which one forces are acting having nature attractive or repulsive for the small distance, then we will call it short range order. Okay, those forces which are acting for the large distance, then we will call it long range order. Okay, now next here, electromagnetic force. Electromagnetic force, that is a force which is acting between the charged particle. Okay, for example, in our nature having beta electrons, okay, we are using fan, we are using our that light also, then all our electricity is conducting in any conductor due to the flow of the electron. Okay, so their electron are having charge. So let we are taking a one charge q1 and another charge we are taking q2, then having the distance between the charged particle, then their force will be active between them. Okay, one force I told you, gravitation force. Gravitation force will be act if they are having the mass of the body, then we can say their force is acting known as gravitation force. Same beta, if mass is not there, charges are there. Okay, that charge can be two electron, electron, proton, proton, neutron, proton, proton, electron. Any two charges will be there. Okay, and having different amount, maybe same amount, then with some distance, then their force will be act between them. Okay, this is mostly similar to this one. Then here this one will be equal to, this one force will be equal to your k q1 q2 by your r square. That is similar our gravitational force. There are two masses body, here the charged particle. This force will be product of the charged particle and inversely proportional to the square of the distance between them. So here as you their proportional sign, then here we are taking our one constant, and that constant equal to your k only. Okay, so here k will be equal to 1 by 4 pi epsilon naught, their constant of the electrostatic. So here k F equal to k q1 q2 by r square. This is the magnitude of the force which is acting between the charged particle. So here we will call this force electrostatic force. Understood? We will call it only electrostatic force. But if we are talking about the electromagnetic force, but electromagnetic force is due to the charged particle, but when charge will be not at rest, when charge will be in motion. Okay, here charge will be at rest, but electromagnetic force we are dividing two type, electrostatic force and magnetic force. Understood? So here electrostatic force will be there only when charge will be at rest only. So as we are sitting here, our also two type of the state possible, we can move, we can sit. Same here for the charge also two type state is possible. Charge we can be at rest, charge can be in motion. So when charge will be at rest, their force will be acting between them, electrostatic force. When charge will be in motion, then surrounding their magnetic field will be created. So due to the presence of the magnetic field, then their magnetic force will be there. So due to the motion of the charged particle, their force will be acting. That force is known as your electromagnetic force. Okay. Now next, when charges are rest, then force is given by the Coulomb's law. I told you beta already. This one force your electrostatic force, and this one force is given by the Coulomb. So that's why this one we will call it Coulomb's law. Okay. Now when charge will be in motion, this also I told you beta charge can be possible in the two state, can be at rest, can be in motion. So this one when at rest will be there, then this one force we will explain by the Coulomb's law. That force is known as electrostatic force, and second state of this one, that charge can be in motion. If they are in motion, then they produce the magnetic field, and they give rise the force on a moving charge particle, and this one force is known as beta what magnetic force. Okay, due to presence of magnetic field. What? Magnetic field. Understood, everyone? Okay. So after this one, electro and magnetic effect. If charge is motion also beta two type, can be uniform, can be non-uniform. But if a motion can be uniform, non-uniform, in both condition, their electric field, magnetic field, both will be active there. Okay. Now electric and magnetic effect are in general inseparable. Hence the name is given as the electromagnetic force. Understood, everyone? What is electromagnetic force? When charge will be in motion, can be uniform, there is a force is acting, electromagnetic force. Like the gravitational force, electromagnetic force act over the large distance, does not need any interweaving medium. Okay, means does not need any medium. There is a note that is specially that there should be medium or not medium. For example, gravitation. Yes or no? Gravitation, earth is revolving around the sun, then there is not compulsory there should be an atmosphere. Okay, but without atmosphere already this force always will be act. Here also that is air, in our atmosphere having air. Yes or no? Medium is air. Okay, but if there will be not air, then this force will be act. Here does not matter, therefore medium should be there or not. Without medium also this type of the force will be act. Okay. So here also beta same like the gravitation force does not need any interweaving medium. Means interweaving means that convey this type of the force between the charge particle, between the magnetic particle, that does not matter there should be medium or not. Okay. Then it is a quite strong as compared to gravity. Yes beta, gravity, I told you gravity means that has come out from our gravitational. If we are talking about this gravitational force on our earth, then we can call it gravity. Okay, that is a earth attractive power, we will call it gravity. Okay, by which acceleration any object is falling downward direction toward our earth, that we will call it gravity, acceleration due to gravity. Okay, so this word is specified only for our earth. If we are talking about the gravitation, then this one for the complete universe. So here this one is a quite strong, means that is gravitation force is having long range order, but this one is more strong as compared to the gravitational force. Okay, if we are bringing two charged particle to magnet for a short distance, they are strongly repulsion, strongly attraction between them. So this type of the force having attractive as well as repulsive nature. Both type of the nature will be there of our electromagnetic force. In gravitation, I told you beta that he is having only attractive nature, but here that can be attractive as well as a repulsive. That is depend upon your type of the charge. Your charge are the same type, positive, negative, then force will be between them repulsive. If we are taking the opposite charges, positive, positive, then force will be act, but that nature will be a attractive nature. Understood, everyone? Okay, next topic, our after this electron, that is short or long range. That is short range order beta. This one not having long range order, that is short range order. Means its effective will be for the short distance, not so much large distance as compared to the our gravitational force. Okay, next our force beta. Here I told you there is a four type of the force available in our nature. That is our weak force. Next, weak force beta, not in your syllabus, but we will discuss about this one. That is acting between the particle. Between the weak force means by name we can say that is the weakest force in our nature. Okay, in that is in certain nuclear process, beta decay of the nucleus, and in beta decay nucleus emit an electron and the uncharged particle call it anti-neutrino. Okay, in higher classes we will discuss about this one anti-neutrino. Till now that is not in our syllabus, so you can learn this one only, that weaker force is so much weak force which are acting between the charged particle when your beta decay of the nature our decay happening. Okay, so weak force is not so much weak as the gravitational force, but much weaker than the strongest nuclear force. Okay, as compared to the gravitational force, that is not so much, but as compared to electromagnetic and our strong force, it is so much weak. Understood, everyone? So next, our fourth type of the force, I told you there are four types of force. That is strong force, strong force, strong force. Okay, there are four types. First we have done about this one gravitation force. First, gravitation force, gravitation force. Next we have done about this one, our next force is your electromagnetic force. What? Electromagnetic force. And third one I told you, beta, that is weak force. That is weak force. And your last one, your fourth one, that is your strong force. What? Strong force. Okay, now strong force, we will discuss about this one strong force. This strong force, but by name only we can decide that is our strongest force in our nature. Okay, strongest force in our nature. Okay, in our nature, where it is acting? No, this one is acting inside our nucleus of the atom. Okay, strongest force in our nature, which is acting between proton and neutron inside nucleus of atom. Understood? Your atom is having, already in chemistry you have done, that is your atom. Inside the atom having your nucleus. Okay, there is a nucleus, and in nucleus having but a combination of neutron and your proton, and surrounding their electrons are revolving around the nucleus. Yes, na? Surrounding of the neutron, that is nucleus, electrons are revolving in your K element, that is a different procedure. Then between them proton and neutron is available there, then between them having their forces, that's why they can be stable inside the nucleus. Otherwise what happened? Because your neutron is neutral only, not having any charge, proton is a positive charge particle, and electron are your negative charge particle. And in last force we have done that if there will be positive then they can repel with each other, if there will be positive negative then they can be attract with each other. So here with a positive, proton your positive, electron your negative, if this one force will be not act, strong force will be not act, then what happened? Positive and negative both will be attract with each other. If your electron will be stable, not moving in the round in circular motion, then both will be attracted with each other, then there will be no formation of the electron, but continuously electron are revolving around this one, that's why they can, this one electron will not fall down inside the nucleus. Okay, and proton and neutron, this proton also not going toward the electron, because there is a force is acting between proton and neutron, which is bound between proton and neutron, and that force is known as the strongest force in our nature. Okay, otherwise there will be not formation of the atom is possible. So your strong is your strongest force in our nature, which is acting between your proton neutron inside our nucleus. Okay, beta. So we discuss about there four type of the forces: gravitation force, electromagnetic force, weak force, and our strong force. Clear to everyone? So beta, before this one we discussed about what is physics. Okay, what is the need of the physics? First beta, if you want to easy this one physics, we have to understand what is physics. Okay, then you can feel your subject here easy. Otherwise you will feel that is so much stuff, we can't do this one, we can't explain their numericals. Then if you will think that relate with your real life, okay, then you can feel this one here easy, you can understand better. Okay, next our topic beta unit and measurement and dimension. Okay, in previous first one part is not so much here important for your exam, but is important to understand your physics and to convey it this one to another person. Okay, but if you not understand what is physics, why we are using it, why we are reading, how we are applying this one, how we can understand this one, so if your answer will be not there for it, then it will be not easy for us. Okay, that's why that is first part is not important for your exam, but for your life that is so much important as compared to another topics. Okay, so our next year topic is starting unit and measurement. Your unit and measurement. Your unit and measurements. Okay, then in this one we will read about the unit of the measurements, unit of the measurement, why we are using units, and what is the need of the measurement. If we are taking any quantity, then what is the need of the quantity. Okay, then if we are moving some distance, then what is the need of the measurement. Okay, because so much important, if we are going from here to another place, then there should be known about how much distance we have to travel this one. So there is so much important of the measurement. Okay, if that someone told about the telescope, that you know, now you know about the information of the universe. Okay, universe information, then where is the earth available in our what is the position of the sun in our universe, what is the position of another planets in our universe. So complete information about our universe only we can explain with help of the bit of physics only, because here without measurement we can't explain what is the position of these planets, what is the position of the our galaxies, moon, this type. Okay, so measurement is so much important topic. If you are in daily life beta, if you are bringing milk from anywhere, then there also so much need of the measurement. Yes or no? If you are taking soaping, then also need a measurement. So unit of the measurements, there should be but a unit only. Without unit you can't explain the measurement, because your name is your identity. Yes or no? If someone is explain about you, then there should be no name about you na. Then what is your name, then only can tell about you. Yes or no? So unit also that is a so much important for any quantity. Okay, then in which unit we are measuring. For example, if I am writing here 5, okay, can you tell me this one 5 is your time? We are talking about any length, we are talking about any mass. Yes or no? So if I will write here after this one 5 kg, easily you can explain it, that is our mass. Yes or no? How you can understand this one? With help of unit. Clear to everyone? Okay, so with help of the unit we can identify. For example, if I am writing here with a 10, can you tell me what is 10? No. But if I am writing here after 10, that is second. After 10, if I am writing here second, then easily you can tell that is we are talking about the time. Clear? So here 10 second, that is your time only. Understood everyone? So there is a necessary for the unit only. For example, then another you can say, beta, if I'm writing here 15, then if I'm writing here 15, then at last of this one I'm writing here m. Means easily you can explain about this one. We are talking about any length of any object, that is a distance. So here will have 15 meter. So next your system of the unit. Your unit is having but a system. Okay, we are talking about our unit also dividing into different part. That can be your MKS unit. Yes or no? CGS unit. Done na this one? CGS unit. Okay, MKS, different type of the unit are available, but beta in some country there is a CGS unit using, there some country using their MKS, somewhere there are different type of the unit using. So we can't explain their unit according to our international level. Okay, if someone will be, some scientist is talking about any unit, any term, that should be measurement should be in single units. That's why for the international talking between them, there is a unit is given, that is your SI unit. Understood? The system of the international. Okay, so your unit are having different type, beta CGS, MKS, PW, that is different unit, but that all units should be in a one wave to convey with each other. That's why that is given in form of the SI unit, standard unit. Okay, everywhere that if we are solving any question, first you will convert all units if given, not given in SI unit, then convert into SI unit, then easily you can solve your question. Next your topic beta, you will read fundamental and derived unit. These all units beta quantities that we will convert into two types here, fundamental and derived unit. Okay, fundamental means basic units. Okay, we can't explain these units from the another units, they are already base. Okay, already base. For example, if your kg is written, can you derive from another unit this kg? No, already this one your fundamental base. So your fundamental and derived unit, already this one your fundamental base unit, that we can't derive from another unit, that's why we are calling it fundamental or base. Next your derived unit, derived means we can derive from the fundamental unit. For example, that is your force. Yes or no? Force. Known everyone about force, done already. Force is the combination between a charge or distance, like this one. Okay, so that unit you will form it, then it will be come out from the fundamental units. In detail we will read later on. So your dimension of the physical quantities, your physical quantity, what are the dimensions? Then dimension we will measure in your mass, length and time only. Okay, dimensional analysis and their application. If we are making the dimension of any unit, then how we can apply this one, what is the use of this dimension formula, then we will read. And next topic will be our list count and significant figure. Then if we are measurement of the any instrument, then what will be list count of that instrument, and how you can find the significant figure, you can say their round of figure, how you can find. And last one beta, error in the measurements. Okay, if we are doing the measurement of any instrument, okay, in practically if we are doing in our lab any measurement, then how much error will be there? Understood? That if any object, if we but in lab having there is a many instrument are available, but their error, if we are doing the practical, then during the practical time there can be error. That error can be due to instrument, can be due to your carelessness. Yes or no? Okay, during the experiment, then for electricity, this one experiment we are doing, then maybe due to the heating effect that there is some error in the reading of the instrument. Okay, there is a different way to coming error in our measurement. Okay, so here we will read our type of the errors, how we can find out these errors from our instrument. Okay, these are the topic of our next part, units and measurement. Later on we will, in next class we will discuss about these part. Okay, thank you.